Welcome students. In the previous class we discussed about Newton's first law, then second law. Among that, first law says force and motion. That means how force affects the motion. Second law is used to find force. That means from second law we get F equal to ma. That means Newton's first law is about force and motion or to change inertia. Then second law is how to find force, that is F equal to ma. Now we are going to discuss about third law. Before that, from the second law, one more things you want to remember. From second law we know that is F is equal to ma, that is m into a is v minus u by t. F is equal to ma. In that m into a is change in velocity by time. Here, how the rate of change of momentum or force affects with the time. See, when a player catches cricket ball, when a player catches cricket ball, he lower his hand. While catching, he lower his hand. For what purpose he is lowering their hand or his hand? See, when he lower the hand while catching, time taken to catch the ball can increase. Time taken to catch the ball can increase. That means the time taken to stop the ball can increase. That means from this relation, F equal to m into v minus u by t. Here t, when the time t increases, rate of change of momentum decrease. That means force can decrease. The force acting on his hand can decrease, so he can avoid injury. That means he can avoid getting injury in his hand. For that he is lowering the hand. For what purpose he is lowering the hand? By lowering his hand, what is the advantage? Time can increase so that the rate of change of momentum can decrease. That means the force applied on his hands can reduce them. Another example, when an athlete in a long jump or high jump, there is a foam bed or sand bed. Why the foam bed is used when an athlete in a high jump or pole vault case, in a pole vault jump? Then what is the advantage of using foam bed there? Or in a high jump they are using sand bed, otherwise can use a foam bed. What is the merit of using it? When using this foam bed or sand bed, that means time of falling or time taken to come to rest can increase. That means time increasing. See, when the dividing quantity time increases, force can decrease. That means rate of change of momentum. That means change in momentum in each second can reduce. Change in momentum in each second, that means force acting on each second can be reduced so that he can avoid, or the athlete can avoid to getting injury. These are the advantages of using what is using to catch a cricket ball by lowering his hand. Otherwise, in the case of an athlete, why in a pole vault or high jump use foam bed or sand bed. In long jump also we use sand bed to avoid what is injury. How there we can reduce injury by time of falling increasing. Time of falling increasing, that means the time taken to come to rest can increase so that the force acting there we can decrease. That is the application we getting from second law. That is so from first law what we discussed about force and motion. That means to change a body moving along a straight line, we want to apply force. Another one is the a body at rest, to change its state of rest we want to apply force. Second law is used to derive force, that means F is equal to Ma. From second law we getting. And also why we lower our hand while catching, lower our hands. Why lower hand when we catch a cricket ball? Try to remember it. Answer. What is the advantage? We can reduce rate of change of momentum or force acting so that injury can avoid. Another, why we use a cushion bed or sand bed for long jump or high jump. Why? Here also by increasing time, rate of change of momentum can decrease so that we can decrease injury. Now we are going to discuss about Newton's third law. See, when an object apply force, when an object apply a force on another object, suppose when we walk, that means when we walk, we exert a force on the ground. That means then the ground is another object. That means when an object apply force on another object, suppose an object apply force on another object, that means the second object, suppose this one is the first object. When an object apply force on another object, the second object, that means simultaneously, that means at the same time, apply force on the first object. Here, first object apply force on the second object. Then the second object instantaneously, that means at the same time, apply a force on the first object. These two forces, when we consider, here the two forces, they are equal. Here the two forces exerted by each of these objects are equal. Each of these object exerted force, is the force are equal? Yes, the force here acting are equal. In which direction? Is the force is in the same direction? Is the force in the same direction? No. The force is acting in the opposite direction. Here the force acting in the opposite direction. Once again, suppose one object exert a force on second object. Then what does the second object do here? The second object exert an equal amount of force on the first object at the same time. Here, force they acting are equal. The force acting here equal. Is the force are in the same direction? No, that forces are in the opposite direction. Again, if these forces are acting on the same body, no. these two forces acting on different bodies. See here, first one is exerting force on second one, that means to the second object. Then the second object exerting a force on the first one, that means forces are equal. They act in the opposite direction, but act on different bodies. They act on two different bodies. The force exerted by first object on second, if we consider as action, if we consider as force acting on first to second as action, then the second exerted force on first one, that is the reaction. So force acting on first on second is the action. Then the force acting on second to first is the reaction. What about these two forces? They are equal, but in opposite direction. So here we can write action and reaction equal to reaction, but they are acting in opposite. So we put a negative sign here. We put a negative sign or minus here because these two forces are equal, but they are acting in the opposite direction. Action is the force exerting on the body, then on a body, then the reaction is exerted by that body on the first object. So Newton's third law we can define in another way also. For every action there is equal and opposite reaction. How we can define? For every action there is equal and opposite reaction. For every action there is equal and opposite reaction. This is the Newton's third law. Now some questions to you. Suppose a body A exert a force on B. So let it be action. Let this force is action. Then B exert a force on A. What it is called? What that force is called? Yes, try to say. What that force is called? A exerting a force on B, that we used to say as a reaction. Then B exert at the same time a force on A. And what that force is called? And it is called what is a reaction. Now another question is, these two forces are equal or not? That means action and reaction are equal. Yes or no? Yes, they are equal. Another question, that two forces acting in the same direction? No, they are acting in the opposite direction. Now we can take the case of when we walk, what we do. While walking, what actually we do? How you walk on the ground? To walk, suppose you are moving to this direction. Then your leg exert a force in the backward. That is the action. Then what does the ground do? Ground exert a force on your feet. That is the reaction. Now, now we discussed the action and this reaction. They are equal and opposite. Suppose a horse pulling a cart. There is the action and reaction, they are equal. Then how the cart is moving? That means a horse pulling a cart. Suppose horse exerting a force on the cart, that is action. Then cart exert a force on the horse, that is reaction. They are equal and opposite. Then how that cart is moving? For moving, that horse exert a force on the ground. Then the ground exert a force on the horse. Because of that, horse can move forward. So the cart also moves. How? We know that a horse exerting a force on the cart, then the equal force exerted by cart on the horse also. Then how that one is moving means at the same time horse exert a force on the ground, that is action, and then it get a reaction force from the ground because of that it is moving. Another example, when we see how there is action and reaction. Suppose when we swim, but we exert a force in the backward on the water, then the water gives a thrust or forward force, that is the reaction. Because of that we can move while swimming. That means there is also action and reaction. And another example, when we jump from a boat. When we jump from a boat, that means we exert a force on the boat. That means if we exert a force on the boat, then if we take that is action, then that means the boat exert a force on our leg, there is action and reaction. That means when we jump forward, the boat moves backward. There is also action and reaction. There is also action and reaction. That means to jump to shore from a boat, we want to exert a force on the boat. If it is action, then the boat gives an equal force to us or on our leg, in our leg, that is reaction. That means so that we can jump to the shore, and at the same time that boat moves backward. There is also action and reaction. There is also action and reaction. We can take another case. When a gun fire a shot. See, at first this gun exert a force on the shot. Gun exert a force on the shot. When gun is used to fire a shot, then gun exert a force on the shot and it moves forward. And the shot moves forward with a high velocity. Then the shot exert a force on the gun. What exerted? That shot exert a force in the backward. Because of that, the gun moves backward. That is called recoil. What it is called? Recoil. Okay. Now, when we fire using a gun, that means when we fire a shot from a gun, what is the action or what is the reaction? What is the action and the reaction in that case? That means a gun exert a force on shot. Gun exert a force on the shot, that we can take as action. Then with that the shot moves forward with very high velocity. Then what does the shot do? That shot exerts a force, an equal force on the gun. Because of that, a gun moves backward and that backward motion of the gun is called recoil. R-E-C-O-I-L. Recoil of the gun. See, here the velocity of the shot is very high. That means it is accelerating at a high speed. That means it is accelerating at a high velocity. But here you see the gun. Here you see the gun is moving backward with a very small velocity or accelerating with a very small velocity. See, here action and reaction are equal, opposite. Why they are not accelerating? Why they are not accelerating at the same velocity? Because the mass of the gun is too small or too smaller than, that means mass of the shot is very small compared to the gun. Mass of the shot is very small compared to gun. Even though the force are equal, they are not accelerating at the same rate because their masses are not same. Because of their masses are not same. Because of that, they are not accelerating at the same velocity. They are not accelerating at the same velocity. Why? Because their mass is not same. Their mass is not the same. Okay. Here you see. Now we discussed so many examples for action and reaction. Which are the examples we discussed when we walk along the ground? The force which is exerting on the ground is the action. Then the ground exerts an equal amount of force in our feet, that is the reaction. Another example, when we swim, we exert force on the water in the backward, that we can consider as action. Then at the same time, water exerts a force on our body, that is the reaction. So there is also action and reaction. And when we fire a shot from a gun exerts a force in the forward direction. Then the shot exerts a force in the backward direction. Here the action and reaction, we cannot say which is taking place at first. They are taking place at the same time. When there is action, there is reaction also. So which one is taking place at first, we cannot say. That means both are taking place at the same time. When there is action, there are also reaction. Now some questions to you. What do you want to know about Newton's third law? What is about Newton's third law? For every action, there is, okay, for every action, but here will come reaction. That means action is equal to reaction. Why this negative sign? Because they are acting in the opposite direction. Then another question, is the action, there are two bodies, first body and second body. If the action is on the second body, then the reaction is on. If the action is on the second body, then reaction is on the first body. They are acting in two different bodies, not on the same body. Because of that, they are not cancelling each other. If the action and reaction are equal and opposite, if they act on the same body, they cancel each other. But here they are not acting on the same body. Because of that, they are not cancel each other. Because when we walk, we exert a force on the ground. That is the action. Then the ground exerts a force on us. That is the reaction. That means action on the ground, reaction to us. When we swim, action is on the water, reaction on our body. When we jump from a rowing boat or from a boat near the shore, action on the boat, reaction to our body. Okay. Then when we fire a shot from the gun. Action is only shot, reaction to the gun. Now, why they are not accelerating equally means because of due to the difference in their mass. Because of due to the difference in their mass. Now, we want to discuss about what do activities given there. Suppose why these action and reaction are equal and opposite, then also they are not accelerating equally. See, here on picture is given for you in that. See, two children, see, they are standing on a trolley. Now, they are carrying each other. See, this boy is carrying a bag with a sand. That means a heavy object. And when he is throwing this bag to this girl, his cart or trolley is moving backward. And when she is carrying, that means when she is catching this on, she is also moving backward. That means this trolley is moving back and this girl is also, that means they are moving equally in the opposite direction. Okay, they are moving, we cannot say equally in the opposite because, but they are moving opposite, but their masses are not the same. So we cannot say they are equally accelerating. They are not equally accelerating because their masses are not equal. Now, instead of this, if two persons standing on this trolley and another trolley there is only one, now you can see when the mass increase, that one moving with less on this side, and where the side with less mass, that moves more. So, why they are not equally accelerating means their masses are not equal because of that. Now, we want to discuss about law of conservation of momentum. Law of conservation of momentum. Suppose we can take two objects. First object A of mass M. So it is taken as MA. Now another object B and its mass is MB. These two objects moving with the velocities UA and UB. Now this UA is greater than UB. Okay, consider two objects A and B of mass MA and MB moving along a straight line. Moving along a straight line with velocities UA and UB. See, these two moving along a straight line MA. This another body MB. See, this UA, UB. Now this UA is greater than UB, so these two collide after some time. Let T be the time taken for collision. After the collision, this A moves with velocity. MA moves with velocity VA, and this will move with velocity, that means MB moves with the velocity UB. Moves with velocity UB. Now, here you see velocity of A is changes to UA is changes to UA is changes to VA. That means its momentum changes. That means object A exerts a force on B. That means during this collision, object A exerts a force on B. That means the force exerted by A on B, and also its velocity of that means V changes UV to VB. That means its velocity changes. That means that also exert a force on this side. A. Now, first of all, we can find out change of momentum. Change of moment of A and B. Change in moment of A is equal to, that means this is the change of moment of A. Similarly, change of moment of B. And change of moment of A is this one, MA minus MA Here similarly this one. We know what is rate of change of momentum. We get by dividing with the T. This rate of change of momentum is due to the force acting. This rate of change of momentum is due to the force acting. So force acting, that means A on B, that means F A B is equal to, that means the rate of change of momentum is equal to M A V A minus M A U A whole divided by this T. Here also force exerted by, that means B on A is equal to, force exerted by B on A is equal to this whole divided by T. We know by Newton's third law, force exerted by A on B is equal to force exerted by B on A. They are equal but opposite. So this we can write as M A V A minus M A U A divided by T is equal to minus, this minus is common to all, so we put this in a bracket, M B B B minus M B U B divided by T. See, T is here both sides that we can cancel. Now this T and this T cancel. Now we are going to multiply with this minus. See, once again, force exerted by A on B is equal to this one. Force exerted B on this one. By Newton's third law, force exerted by A on B equal to minus of force exerted by B on A. So this relation we got. Now this relation I am writing here. After cancelling here, see. What is here? M A V A minus M A U A is equal to, with the minus multiplying, minus M B B B minus of minus, this become plus, that is M B U B. Now see, after multiplication we get this way. Now these minus terms we can shift it to this side, and this minus term to this side to make it positive. See, that means M A V A. When this here will come into plus, M B B B is equal to, this minus term here will come as plus M A U A plus here this term. See here, this is the momentum of A before collision. This is the momentum of B before collision, equal to, this is the momentum of A after collision. This is the momentum after collision for B. These are equal. That means momentum before collision is equal to momentum after collision. momentum before collision is equal to, this is the momentum before collision, is equal to, this equal to momentum after collision. So, here no external force is acting. In this case, there is no external force acting in that case, because that two moves with the same velocity. This shows the law of conservation of momentum. That means if there is no external force acting on a system of particles, the total momentum remains conserved. Total momentum remains conserved. So, we got the law of conservation of momentum. In this case, what is the relation? That is momentum before collision. That is MAVUA plus MBUB is equal to momentum after collision. That is MAVA plus MBVB. Okay. Now we discuss about Newton's third law and about the law of conservation, and some questions. Again, you want to give answer. Okay. Give. Okay, students, I told you before that some questions to you. Among that one is what is actually a recoil of gun? Okay, recoil of gun. Second one, what actually law of conservation of momentum? Says. Third one is how action and reaction related. And next one is the action and reaction act on the same body. And see these questions. What is actually recoil of gun? Now you can remember its answer. Say, what is it? When a shot moves forward from a gun, the gun moves backward with a small velocity, and that motion of the gun is called recoil. Okay, this is the answer you want to remember. I hope you got this answer before the answer getting from me. Okay, next one, law of conservation of momentum. What says actually about the law of conservation of momentum? What is from your side? If there is no unbalanced force act on a system of particles, then the total momentum remains constant. Total momentum remains constant. This is the first question. This one was second one this. And third one, how these action and reaction are related? How? What is the answer to how is these two related? How these two are related? That means they are equal, but in the opposite direction. To show opposite direction, we use this negative sign. Can you remember some example about action and reaction in our everyday life? Yes, when we walk along the ground, we exert a force on the ground. That we can consider as action. Then what does the ground do? Ground exert an equal amount of force in our feet. Because of that we can walk. So that is understand. Another example, when a rocket moves upward, what does the burned gas inside it exert a force in the downward, that is on the atmosphere. Then the atmosphere exert a force on the rocket, so it moves upward. Another example, when an inflated balloon, when we release, what happened? Air push it in the backward. Air inside it push backward. Then the balloon moves forward. That means the air pushing out is the action, then the air exert a force, that is the reaction, so the balloon moves forward. That is also example for action and reaction. Now another question is another question to I asked how these action and reaction they act on the same body. They act on the same body or different. They act in two different bodies. That means if the action is on one body, then the reaction is on the another body. Okay, now these are the things you want to remember from our discussions. Today we discussed about Newton's third law. That means to every action there is equal and opposite reaction. Then about examples related to show action and reaction. With this all we can wind up today's class. Okay.